We are Team CE9, and in this video we will be presenting an experiment that demonstrated mass transfer and diffusion in liquids and gases. So, first of all, what is diffusion? Diffusion is a form of mass transfer that occurs primarily in fluids due to a difference in concentration, where particles move from an area of higher concentration to lower concentration. The rate of this movement depends on the diffusion coefficient, which is a fundamental parameter in Fick's law of diffusion as shown, where J represents the mass flux, dc by dx the concentration gradient, and the diffusion coefficient, which will be calculated later on. Mass transfer by diffusion is crucial in industries like petrochemicals, food packaging, and water treatment. It ensures efficient separation and purification for processes like distillation, crystallization, and extraction, maintaining high-quality product. In food packaging, diffusion impacts material permeability, affecting food freshness. In water treatment, gas-liquid mass transfer optimizes energy and emission control. Innovations like Suhla's eco-friendly advancements and new tray designs enhance efficiency. The objective of this experiment is to determine the diffusion coefficients for liquids and gases, using experimental setup, and to validate the diffusion principles by using the observed data. We are also aiming to investigate the factors influencing the diffusion rates, such as concentration gradient and temperature. Two sets of experiments were carried out to investigate the diffusion in liquid solutions and in gases. For the liquid solution experiment, we started by filling a measuring flask with 900 milliliters of distilled water. Then we filled the diffusion cell with 1 molar solution of sodium chloride until it overflows. After that, the diffusion cell was placed into the measuring flask, and the air bubbles in the capillaries were removed using a pipette. We then covered the capillary disc with water and inserted the conductivity probe. The magnetic agitator was then switched on and maintained at approximately 200 RPM. The conductivity value was recorded every 3 minutes, and the results were tabulated. The graph of conductivity versus time was plotted based on the data obtained. The graph shows a logarithmic trend as concentration gradient decreases over time. The difference quotient obtained from the linear area of the curve was 1.88 microsiemens per cm per minute. The coefficient of diffusion was then calculated using the equation with all the values converted to SI unit. The coefficient of diffusion obtained was 6.68 times 10 to the power of negative 9 meters squared per second. Some possible sources of error in this experiment are the impurities in the water or salt solution, leading to a systematic error in the data. Some potential random errors include the variation in the agitator speed or human error like inconsistency in timing.